Hi everybody, this is Mrs. C. I am doing a video for you on solving proportions. I know a bunch of you, when I gave you the Unit 1 assessment, kind of looked at it like, OMG, what is that? Most of you expressed that these top ones that you see up here, yeah, pretty much these didn't freak you out too much. But as you looked further on at the assessment that I gave you, it started to look a little bit suspicious. So I realized I don't think I have many, if any, videos on solving proportions. So it is Saturday in the morning. I'm making my cup of coffee, and I thought, let's spend a little quality time together, and I'll just show you how simple these are really to pull off. So let me adjust my screen a little bit here. Okay. And let me go ahead and show you how the process for solving any proportion. It's the same. The process for solving a proportion is the same as it is for any of them. You just have to do a couple simple steps. The first thing you want to do, let's take this baby one right here. First thing you want to do is make sure that you have a proportion. A proportion is a one fraction separated with an equal sign. Hang on, let me rewind that. What did I say? My son is downstairs laughing at a cartoon. You have an equal sign in the center and a fraction on one side and a fraction on the other. Makes that sounds a little bit better. So you have two values that are proportionate or equal to each other in value. They may look different, like your classic 2/4 is equal to 4/8. They look different, so they're not physically, you could say, alike, but in value, they are both equal to 1/2. And so therefore, they are proportionate to each other. So what we have here is the request to solve the proportion, to find out what the top would have to be. Now you're in Algebra 1. They're not going to make these super simple. They're going to give you a proportion. Let me switch this up. I'm going to put the 7/2 first, and then the x/6. There. Sometimes they put them in opposite order, and it's hard for you to see the relationship. You see how 2 times 3 is equal to 6? That means if you times 7 by 3, you'll get what the x value would have to be to make this proportion true. It would have to be 21. So, if that's right, I have 7/2 is actually equal to 21/6. And we can use something called cross products to verify that. Is it true that 7 times 6, which is 42, is equal to 21 times 2? Well, 21 times 2 is actually 42 also. That checks out. The left cross product, well, left and right, the cross products are equal to each other. And in a proportion, your cross products must be equal to each other. And we're going to really use that rule to help us out. So let me erase that one, because that was a straightforward one. That one shouldn't have thrown you off too much. But just in case it did, let me do another one similar to it. Let's do letter E. We have A/8 equal to 4/3. Now, this is a little bit different, because even if we put the 4/3 in front, let's try it. 4/3 equals A/8. We have a little bit of an issue. Do you see what the issue is if we wanted to do it the way we did the last one? Yeah. The problem is that I can't think of a number that, let me use a little x for fun, 3 times what would give me 8? I can't think of a number that you would times 3 to that would give you 8, because 3 times 2 is 6, 3 times 3 is 9. This is saying to me that whatever I have to times the 3 by to get the 8, it's fractional. And I don't know those in my head. I know my integers, I know my whole numbers, I know the times tables of my whole numbers, hopefully, right? But I don't know every possible combination of number that's not an integer times another number that could or couldn't be an integer that would give me a number. I just don't. And so I need another method to get this. And I'm going to show you it's a very simple, straightforward method. It's using the method we already used. It's cross products. See, if I know that this product has to be equal to the other cross product, I'm going to actually write that. The cross product of 4 times 8, which is 32, has to be equal to, remember I wrote the 32 in the corner here? This has to be equal to 32. And what is this? 3 times a. It's 3a. So you set your cross products equal to each other. So one more time. Oh, hang on. It's okay. Some of you are like, what? That's all right. I got you. This cross product, you write first, right there. Then this cross product, you write next. You write there. And you separate with an equal sign. Then you solve for a. Now, I'm not going to do it. I'm going to actually erase all that because this video is to help anybody on cross products. Want to make sure you come to class understanding the basic ones. If I write it again, I have a over 8 equals 4 over 3. I said cross product that, a times 3, I always put my number in front, 3a. Cross product this, 8 times 4, that's 32. And there you have it. Now all we have to do is solve for a. Divide both sides by 3. A equals 32 divided by 3. 32 divided by 3 is a decimal. I don't know what 32 divided by 3 is. I could get an approximate of 32 divided by 3, which I'm going to ask you for because we're going to be using the number line when we plot points. And when we have fractional points, I'm going to ask you to find the two integers that point falls between. It's as simple as saying how many times does the bottom go into the top. Well, 3 goes into 32 about 10 times because 3 times 10 is 30. 3 times 3 is 33. I went over. I don't want to go over. I want to find the one that I'm closest to, the two numbers on between. So 3 goes into 32 10 times. And there's a little bit left over. There's 2. There's 2/3 left over, but I don't want you to write 10 and 2/3. I didn't ask you to convert an improper fraction to a mixed number. I just said I want you to give me an approximate. And in that case, I'm going to use this. It's about. Okay, so A is about 10. It falls between 10 and 11. So you would want to know, well, which answer am I supposed to box? Like, what is the answer? Well, unless they ask you to approximate or estimate, not estimate, but to round your answer or anything like that, then you are going to be happy to know you don't have to do that. I'm going to make you do it, but you don't have to do that for the answer. The answer is going to be whatever you got. Remember, 3 goes into 3, so you have A is equal to 32 over 3. Now, of course, I would never give you a worksheet without giving you answers. There they are, 32 over 3. Now, if you go back, this is one of those little puzzly ones. I know you've done them before. This was letter E here. So letter E would go wherever you see 32 over 3. And if you see it anywhere else, there it is. You put an E there also. And so if all goes well, this will spell something. Books that were never written, and then it's yours forever, and I don't know. If it makes like a word, you have a feeling. I usually am happy that I find my answer. And that's fine. I just always give you the answers, or always try to give you the answers. Let's try another one. Okay, let's erase this and try another simple one. And then we'll go to some harder ones. Those of you that are bored by what I'm saying, please feel free to fast forward and find me talking about something that doesn't bore you. Let's try one last time y, because y is the same type as the ones we've been doing. 2/9 equal to t over 4. Cross products, right? So 2 times 4 is 8. 9 times t is 9t. Divide both sides by 9, and you'll get t by itself. And then I will switch t to the other side, because that's how I like to see it. 8 over 9. And then I'll come over here, and I'll look to see if I see 8 over 9. And usually that's good enough for me. I see 8 over 9. I don't need more. I don't need to do the riddle. I just want to see that my answer's there. Okay. Let's try one that's maybe a little bit more saucy. By the way, 8/9 is a simple fraction, meaning its numerator is smaller than its denominator. That means it falls between 0 and 1. All numbers whose numerators are smaller than their denominators will be a value between 0 and 1. And I'm talking about positives. So if you see this, then the answer is between the integers 0 and 1, and it's closer to 1. It's almost 1. 9/9 would be 1. So 8/9 is super close. Okay, so we come to one that looks just a scunch bit different. It's letter O. 8/11 equals 3/2y. It may look different, but we do it the same. Cross products, 8 times 2y is 16y. 11 times 3 is 33. Divide both sides by 16. And you get y is equal to 33/16. Now, can we simplify it? Well, does 16 go evenly into 33? No, I don't believe so. I believe 16 times 2 is 32. So it almost did, but almost, only counts in horseshoes and grenades, my grandpa used to say. So 33/16 is my final answer. I do look to see if I can simplify it by dividing out a common factor. But 33 and 16 do not have a common factor that I am recognizing. For example, they're not divisible by 2. 16 is, but 33 is not, so that's not common. They do not share 3, but 33 does, but 16 doesn't. So I'm saying 33/16 I should see over here somewhere. There we go. 33/16, I'm feeling good about that one. Let's try another one. You see how that was no different, even may have looked a little different. Process is no different. I am going to jump to letter I. That one, the process is just the tiniest bit different. Now, I used a color blue, but I don't think it's dark enough. Let me try this one. We have K, which I hate when they use the letter K, plus 5/7. No offense to K, it's a little bit more work for me to write. It's not that much more work, but I don't know, it feels like more work. Okay, whenever you have a quantity, and this is what I'm calling this a quantity. When you have two terms that are being connected by a plus or a minus sign, that is called, it's a polynomial. Now, that's a big fancy word for more than one term that can't be simplified. You can't put k and 5 together and call it 5k. You can when you times, but not when you add. So k plus 5 is simply just k plus 5. Now you need to trap all quantities like this with parentheses. Now I want you to forget what I just wrote and look around the page. Do you see all those quantities? They're called binomials on this page. They're two terms together. Look at letter B. Here and here. I would love for you to get into a habit of whenever you see this, you just trap those babies in parentheses. Look at me. I'm just going to do it all over the page. Wherever I see a binomial, I am trapping it. Now look what I just skipped. Why didn't I trap that? Well, it's not in numerator or denominator. That's why. I only did that to any term that was above or below a fraction bar, because the fraction bar is representing division. And when you're above or below a fraction bar, you are implied in the order of operations that you must do that before division. Now, PEMDAS, please excuse my dear Aunt Sally, specifically states that you're supposed to do addition and subtraction last. And I'm going and telling you, put parentheses around it to tell you to do it first. So it almost seems like I'm breaking the order of operations, but PEMDAS has the P in front. P for parentheses. There really should be an F in front of the P. It should be PEMDAS, because fractions, anything above or below a fraction, are always implied to be parentheses. Now, That was a whole lot of blah, 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 blah. I don't want you to freak out by it. You don't have to understand a whole lot of what I just said. If you just promise me that whenever you see a fraction, you are going to, look, I'm changing colors so you can see me. You are going to, I'm coming down here, put parentheses if there is anything above or below it that has a plus or a minus sign. And again, I didn't do that to that because it is not above or below a fraction bar. I didn't do it to this because there's no plus or minus that I have to worry about. So, if I confused you with that, don't worry about it. Write it down in your clarifying questions on your sheet of your video log, if you're using a video log right now. And then come into class and say, please go over that again. You confused me. I totally did not understand where you were going with that, Mrs. C. Okay, now I'm back to my original problem, which was letter I, k plus 5 over 7 equals 5/3. You see how I put parentheses around that like I told you to. Now I'm going to do what I've always done, which is the cross products. But now when I do cross products, I am going to put the little 3 in front and write the k plus 5, and you see how my parentheses are already there, is equal to 35. That would be the 7 times 5. Now when you see this, you have to do an extra step to multiply 3 times the quantity of k plus 5. You need to use your distributive property, and that's going to be 3k plus 15 equals 35. You're going to minus your 15. This is just a simple two-step equation. When you take 15 from 35, what do you get? 20. Divide by 3, and you get 20 over 3. Again, another fraction, 20 over 3. Can't do anything to that. So I'm coming all the way up to the top. I'm getting k is equal to 20 over 3, and I'm coming right over here because I have an answer key. I'm not going to bother looking over it. I'm just going to see if my answer is there. 20 over 3. I'm good. Let me pick another one. Just go and erase. Let's try B. B has 2. Now, what did I tell you to do first? Because I've erased it. I told you put parentheses before you do anything, and then just follow your cross product. So instead of copying the whole thing, I'm just going to cross product from here. That would be 9 times the quantity of x minus 4 equal to 2 times the quantity of x plus 1. And then I always look back over it to make sure I copied it right, especially when I'm doing a video. I don't want to do this whole thing wrong. And then I'm going to distribute. So I would get a 9x minus 36 equal to 2x plus 2. If this step is confusing you, you need to get your little tushy back to just simplifying expressions and solving two-step equations that have the distributive method. You need a little more practice. You need a little more time to cook on that one. I'm minusing the 2x from both sides. I'm getting a 7x minus 36 equals 1. And now I'm adding 35 to both sides. I'm getting a 7x equal to 36. I'm dividing by 7. I'm getting another fraction, which at this point I'm getting used to. And I'm checking to see if 36/7 is in my answer key. Oh, have I finally made a mistake? 36/7. 36/7. There's a 38/7. Did I do something wrong? I was just thinking to myself, wow, I haven't screwed up once yet. I haven't screwed up once yet. All right, I'm going to go back and try to figure out where I screwed up. Hopefully it's not beyond this point. You may already see it. I don't see it yet. So I'm double checking. And when I'm double checking, let me change my color so you can see what's going on in my head. When I'm double checking, I am running through all the process over again. And then I'm looking to see if I wrote it right. So that would be the 9x minus 36. This would be 2x plus 1. I'm happy with this one. Then I minus 2. This is around where I was thinking to myself, man, I haven't even screwed up yet. So minusing 2, 9, 8, 7, minus 36. That goes away. That's 1. Adding 36. Adding 36. Adding 36. You see it? Okay. When I'm supposed to add 36, I wrote a 35. So I was supposed to be adding 36, not 35. So those of you way back when I did it the first time that were thinking, where did she get 35? I don't know where I got 35. So 36 plus 1 is 37. And there's my, isn't that what I wanted? I'm going to go back. Nope, it was 38. Okay, still screwing up somewhere. So this was 36, add 36, add 36. 36 plus 1 is 37. And 37 divided by 7. So is there something else wrong? Okay, so the last thing I was trying to figure out, I paused it. That's what I'm saying. Okay, like I'm coming back because I am. And when I came back, I found one mistake and figured I was home free. And then I thought, look, checked, and it's still not working. And what have I done wrong? Go back and, oh my goodness, I did not really make this mistake, did I? Come back here to where I went check. I agree with my process so far. Come right here. 2 times 1. And I even agreed that I thought 2 times 1 was 1. Okay. This just goes to show you that everybody makes silly mistakes. Even me. Well, sometimes I want to say especially me. And all you got to do is find them. I don't re-record this video. You learn from my mistakes. You see that it's really totally okay to make them. You're going to make them. What did I tell you at the beginning of school? Embrace failure. It's the stepping stone to success. To screw up is one thing, but to find the screw up is even better, because you get better and better at finding your errors and really looking at your work and your process and looking at it critically so that you can find your mistakes. So now when I find my mistake here, that 2 times 1 is not 1, 2 times 1 is 2, I need to bring that down here. When I add my 36 to 2, that's how I wind up with the 38 over 7, which now matches the 38 over 7. This is what I refer to as a silly mistake, not a conceptual mistake. When you guys will make mistakes on quizzes, some of the mistakes will just be silly mistakes. Some of them will be serious mistakes, conceptual mistakes. They're the ones that you're doing because you don't understand what's going on. This is one mistake that everybody makes eventually, and it doesn't have anything to do with you understanding what you're doing. It's just if you do math long enough, you're going to screw up. Now, the video is getting long, and I always say I try to keep it under 15, but when I screw up, it does eat away a little time. So I want to go to letter D, and this will be the last one that I do, and I'm going to work super, super cautiously so I don't mess up for you, though I'm glad I finally did. I think it only took how many videos that I've made this year to screw up the first time. Okay, I've got a 2n plus 3 over 4 equal to 5n minus 1 over 6. Now, I'm going to put my parentheses around my quantities like I told you. Always do. Should do it on the original. And I'm double checking right now just to make sure I copied it right. And I did. So I'll do my cross products. 6 times 2n plus 3 and 4 times 5n minus 1. Some of you might be saying, can't I just do the distributive method without writing it? I don't know, can you? I guess that would be my question. If you can do it and not screw up, then go for it. I would recommend maybe on a quiz that you show this step just to make sure you don't make a silly mistake way up at the top. So, and take it from me, I've made mistakes, right? So I know. Here we have 12n plus 18 equal to, that's a 20. Let me just do that. There we go. 20. Where's my equal? N minus 4 didn't come out. My equal is supposed to be here. This is supposed to be an equal, not a negative. Okay. I'm double checking. I'm doing that again. Now let me change color so you can see what I do. Before I move forward, I always go back. I do this again. 6 times 2, that's 12n. That's 18. That's 20n. That's negative 4. Okay, feeling good. Again, I felt good before and I had screwed up. Now I want to separate letters from numbers. I know you guys have a tendency to do this, minus the 20n, bringing your letters over to the left. I don't do that, but for you, I'm going to, because I have a feeling that's what you're used to. A negative 20 and a positive 12 is a negative 8. N plus 18 equals negative 4. I'm going to minus the 18. I'm going to have a negative 8, n equal to the quantity of a negative 4 and a negative 18, which is going to be same sign sum. Keep the sign. That's going to be a negative 22, is it? 18, 19, 20, 21, 22. Divide both sides by a negative 8. Okay, I'm running out of room. I'm getting n is equal to 20. Negative over negative is positive. So let's come over here. Let me make sure I'm right. Yeah, I'm right. Okay. I don't want to go through the explanation if I screwed up. All right, so I have n is equal to a negative 22 over negative 8. Negative divided by a negative is automatically a positive. So I don't have to show my negatives anymore because they'll wind up becoming a positive. So what I have is a 22 over 8, right? Now, 22, so again, negative 22 over negative 8. Negative over negative becomes a positive, so it becomes, what is 22 over 8? Well, if you look over here, you don't see 22 over 8. And you might think, oh my gosh, she screwed up again. No, 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 I wasn't going to screw up again. 22 over 8 can be simplified because you always ask, do they have a common factor? In common. Now, all the others we've done haven't. This one does. What number goes in evenly into both? What number is a factor of both? 2. 2 goes into 22 11 times, and 2 goes into 8 4 times. So the actual proper value of n is 11 over 4, not negative, because remember, the negative divided by the negative became a positive. So then the value I'm looking for is 11 over 4. And you can see the 11 over 4 is there. Now, I want you to take a look at all of the values that are still here that I haven't done yet. There's plenty of practice still to do. So if you want to come back here, and let me just erase it so it's nice and clean. You don't have to rewind. Okay? You don't even have to rewind. And what I'm even going to do here, look, I'm erasing all the quantities. I'm even coming here and I'm erasing everything I already did. Because what I find is even though I did the problem already, do it again. If you forget that I already did it, it doesn't matter. Just do it over again and see if you can get it right. So there's your answers. There are your problems. And go ahead and try some of these and see if you can get them right. The best thing that could probably happen is you try a couple, you get them right. You try a couple, you get them wrong. Write them on your log. Come into class, talk in your group about them and say, look, I watched the video. I got these right, but I couldn't get this right. Maybe your partners can find your error. Maybe you can work together to try to figure it out. Maybe you can call me over and say, hey, what are we doing wrong here? Maybe I can find your mistake. It's all about the practice and the investigation and the learning that we do at home and then the practice that we do in class. So my biggest apologies for making this video almost 30 minutes. Hopefully you did fast forward through a lot of the blah, blah, blah. But I definitely think it's a worthwhile one for you. And yay to getting done my first error, first of many, I am sure. Guys, proud of you. You did awesome. I'll see you in class. And as always, it's Mrs. C. I'll see you on the flip side.